Time-appropriate greetings, everyone, and welcome back. In this video, we are going to formulate and solve a linear program using Microsoft Excel. In this example, we're going to consider a farmer that has 110 hectares of land and wants to grow wheat and barley on this land. Planting wheat costs $100 per hectare, profits $50 per hectare, and requires 10 days of work per hectare. The barley costs $200 per hectare, profits $120 per hectare, and requires 30 days of work per hectare. The farmer has a budget of $10,000 and 1,200 days of work hours. Naturally, the farmer wonders how much wheat and barley should they plant to maximize profit. To formulate this linear program, we first identify the variables of this problem, which are, of course, wheat and barley. And we're going to measure wheat and barley in hectares. We're going to put some dummy values into Excel here, which are just going to be placeholders. Right now, I'm going to assume the farmer will plant 1 hectare of wheat and 1 hectare of barley. Of course, when Excel solves this linear program, the actual solution will replace these two values. The objective of this is to maximize profit. So I'm going to change this objective here to maximize, and I'm going to add profit. Let's enter the coefficients of the objective function for this linear program. Each wheat hectare profits $50, and each barley profits $120. We then have 3 constraints. We have a budget constraint, we have a workdays constraint, and we have a farmland constraint. Contributing to the budget is $100 per hectare for wheat and $200 per hectare for barley. Each hectare of wheat takes 10 workdays, and each hectare of barley takes 30 workdays. And of course, each hectare of wheat takes 1 hectare of farmland, and each hectare of barley takes 1 hectare of farmland. What I've done is I've just created the constraint coefficients, the objective function coefficients, and some value cells for the variables. This allows us to compute, for example, the total profit. The total profit is simply how many hectares of wheat times the profit per hectare, plus the number of hectares for barley times the number of hectares for barley. I can't see it back there, so I'm just going to type D14. So number of hectares for wheat times the profit per hectare, and then we have the number of barley times the profit for barley. We'd enter and we have the total profit if we were to have 1 hectare of wheat and 1 hectare of barley, which of course would be 50 plus 120, 170. I'm going to drag this total down so that I can construct the total budget, total workdays, and total farmland. Before doing that, I have to put absolute references on the variable cells here. So I'm going to put a $sign in front of the 11 so that the wheat doesn't move down, and a $sign on this 11 so that the barley reference doesn't move down. Hit enter and autofill this to the other cells. Now, of course, these ones in the middle don't mean anything, so I'm just going to delete them. I'm going to label this column total, just to be clear. And now what we have is, if we were to construct 1 hectare of wheat, 1 hectare of barley, we would profit $170, we'd spend $300, we'd use 40 workdays, and we'd use 2 hectares of farmland. Now let's put into our sheet the limits that we have on our constraints. The budget must be less than or equal to $10,000. The number of workdays is less than or equal to 1,200. And the amount of farmland is less than or equal to 110. We have $10,000 to spend, we have 1,200 workdays to use, and we have 110 hectares of land to plant on. Now that we've formulated this linear program in terms of variables, objective function, and constraints, let's solve this linear program using Solver. In the ribbon, go to the Data tab and click on Solver. If you don't have Solver in your Data tab, you need to install the Solver add-in. I've linked to the instructions from Microsoft in the description. The Solver parameters require an objective value, a max or a min, and some variable cells and some constraints. The way that we've designed our spreadsheet here makes it easy to fill in this dialog. We're going to set the objective function, or the value of the objective function, the total profit, to a maximum value. We're going to change the variable cells, the values here. So Solver will manipulate how many hectares of wheat and barley there are, and it will set this to a maximum value. Then we add some constraints. We click the Add button. This cell reference, the total budget, must be less than or equal to $10,000. We click Add, and now we can add the next constraint. The total number of workdays must be less than or equal to 1200 days. We click Add. The number of hectares must be less than or equal to 110. Notice how well the design of this sheet lends to filling in this solver dialog. We click OK on the last constraint, and we'll see that they're added here. Ensure that the Make Unconstrained Variables Non-Negative here is checked. We don't want negative values of wheat and barley hectare. And for this solution method, choose Simplex Linear Program. This will use the simplex method to solve this linear program. Click Solve. Solver works its magic, and a dialog box pops up telling you that Solver has found a solution. All constraints and optimality conditions are satisfied. Click Keep Solver Solution and OK. As promised, Solver has manipulated the values in the wheat and barley variable cells, and it's changed it to 60 and 20. When we produce 60 hectares of wheat and 20 hectares of barley, the profit is $5,400. We use all $10,000 of our budget and all 1,200 hours of work, and we're only using 80 hectares of land. As you can see, it is possible that we don't use all of the constraint. There is what we call a little bit of slack here. We would get this same solution if the farmer only had 90 hectares of land to work with. The limiting constraints really are the budget and the work days. We'll speak a little more about that in the next video when we talk about sensitivity analysis. The key takeaway point here, though, is that subject to these constraints, working with this budget, working with this many work days, and working with this much farmland, in order to maximize the profit, this farmer should plant 60 hectares of wheat and 20 hectares of barley, and that profit is $5,400 per hectare.